Okay, Unit 9.1, Radicals Review. So on number 1, we're adding, which means we have to have like terms. So since we have 2 square roots of 5, or not 2, but square root of 5 here and a square root of 5 here, that means we can combine the coefficients. So 5 plus 7 is 12, square root of 5, there's your answer. Okay, number 2, you have a square root of 2, but we also have a square root of 18. So 2 can't break down 2's prime, but 18, we have 2 and 9, 3 and 3. So I have a pair of 3's, so I'm going to rewrite square root of 2 plus, I could take a 3 out and I have a 2 remaining. Well, now they're both square root of 2. Now this one is a single, and this one has 3, so 1 plus 3 is 4. So we have 4 square root of 2. Okay, number 3 is the same concept as number 2. We need to break down our numbers. So 125. I know 5 goes into that 25 times. And then 25 is a perfect square of 5 and 5. So I have 5 square root of 5 minus, and now we need to break down 45. So 45, 5 can go into that 9 times. And 9 is a perfect square of 3 and 3. So here we're going to have 3 with a 5 remaining. So knowing that, 5 minus 3 is 2. So I have 2 square root of 5. And that's my answer. And now I want you to realize you can always check your work. Square root of 125 minus square root of 45 equals this. And I can also do 2 square root of 5. See how they're still equal? That means it's correct. So you could do that on all of these. Now when they start throwing variables in them, like number 7, you cannot do that. But like all of these that have no variables, you can totally check in the calculator like that. Okay. Okay, number 4 and 5. Guys, all you're doing is combining like terms on these. So I have negative 6 plus 9, which is 3. And I have 3 square root of 5 plus 4 square root of 5. Well, 3 plus 4 is 7. This does not simplify any further. 5 is prime, so I am done. Same with number 5. So 8 minus 6 is 2. And 2 square root of 6 plus square root of 6. Well, 2 plus 1 more is a 3 square root of 6. 6 is not prime, but you get 2 and 3. Nothing matches, so that is as simple as it gets. Number 6 is a little harder because we have cube roots. We're still going to break them down though. So we have 32. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. And since it's a cube root, we need a set of 3 that match. So here they match. And I only have 2 remaining, so they cannot come out. I already had a 14, and now I'm taking out a 2. And then I have cube root of 2 times 2 left over, which simplifies to 28 cube root of 4. Bring down my minus 15, and now I'm going to break down 162. So 2 and 81. Now 2 does not go into 81, but 3 does 27 times. 3 goes into 27 9 times, and 3 goes into 9 3 times. Again, it's a cube root, so I need a set of 3 that match. So I'm going to take out a 3, and I have 3 times 2 left over, which is 6. Negative 15 times 3 is negative 45, cube root of 6. Now this is a cube root of 4, and this is a cube root of 6, therefore these are not like terms. So this is my answer. Okay, let's look at number 7. Number 7 is kind of a mess, but it's not bad. So these are, again, cube roots. And I have letters. I know 3 goes into 5 one time, but if you struggle with that, you can draw them out. I have 5 x's and 6 y's. 1, 2, 3, 4, 5, 6. Okay, knowing that, I have a cube root, so I can take out a set of 3. I could take out sets of 3 that match. So I have a 4 and I have an x already. Well, if I take out another one, that means I have x squared. And I take out 2 y's, so I have y squared. And I have the cube root of my remaining, which is x twice, or x squared. Bring down my plus. I have 5. Now I have x twice, and I have y 6 times. Okay, so knowing that, I can't take out any x's because there's only 2 of them, and I need a set of 3. And I can take out 2 y's. So I get x squared's already outside. I can take out a y squared. And I have x squared remaining. Now, to combine these, everything after the coefficient has to match. X squared, y squared, x squared, y squared, cube root of x squared, cube root of x. So they do. So 4 plus 5 is 9. X squared, y squared, cube root of x squared. Okay, look at number 8. Number 8 is just distributing once, not double distribution like 9 through 12. So we have the square root of 6 times 7, which is the 7 square roots of 6. We have the square root of 6 times negative square root of 3. Well, a positive times a negative is a negative. And since they're both inside the radical, we can combine them. 6 times 3 is 18. Now we need to break down our 18. 6, remember, doesn't break down, but 18 might. 2 goes into 18 9 times, 3 and 3. So I can take out a 3, and I have a 2 remaining. Well, those are not like terms, and they cannot simplify, so there's your answer. Okay, on the next one, we have to double distribute because we have 2 terms times 2 terms. So I'm going to do the first term times both terms and the second term times both terms. So we're going to multiply a total of 4 times. So 5 times negative 2 is negative 10. 5 times 2 square root of 5. Well, remember, outsides gets multiplied, insides gets multiplied. 5 times 2 is 10. This doesn't have an inside, so it just stays square root of 5. Then I have negative 4 square root of 5 times 2. Negative 4 times negative 2 is positive 8 square root of 5. And then negative 4 square root of 5 times 2 square root of 5. Well, negative 4 times 2 is negative 8. 5 times 5, because they're both inside, we can combine them, is square root of 25. And now we want to simplify. So negative 10 doesn't simplify, and there's no like term. So I'm going to bring it down. These are both alike. 10 plus 8 is 18. And then I get minus 8, but the square root of 25 equals 5, so I can multiply 8 times 5, which gives me negative 10 plus 18 square root of 5 minus 40, because negative 8 times 5 is negative 40. And then these two are like terms, so I get negative 50 plus 18 square root of 5. So number 10, 11, and 12 are just like that. So let's try number 10. Okay, so again, I have 2 terms times 2 terms, so I'm going to distribute. 3 times 6 is 18. 3 times negative 2 square root of 5 is negative 6 square root of 5. 4 square root of 5 times 6, well, 4 times 6 is 24 square root of 5. 4 square root of 5 times negative 2 square root of 5, well, 4 times negative 2 is negative 8. 5 times 5 is 25. Okay, so again, 18 doesn't have a like term, so I bring it down. These are like terms, so 24, negative 6 plus 24 is 18. And then negative 8 times the square root of 25 is 5, which gives me negative 40. Woo. So I get 18 minus 40 is negative 22. So I get negative 22 plus 18 square root of 5. I think my pen is dying. That's a 5. Okay, let's try number 11. And I get another color. Okay, so knowing this is squared. Squared means twice. It does not mean you could just square the insides. I actually have to write it twice. So I'm going to kind of cross off the squared and build another parentheses. So that way I don't have to write it twice and I can just write it once. And now that's twice squared. And now you do the exact same thing as you did on number 9 and number 10. So now everything here is inside the house, so you are multiplying everything. So square root of 3 times square root of 3, square root of 9. Square root of 3 times the square root of 18. Well, 18 times 3 is 54. 18 times 3 is 54. And then 18 times 18 is 324. Now I know these two should be perfect squares because I multiplied the same thing twice. The square root of 9 is 3. And then the square root of 324 should be 18. And it is. And I have 2 square roots of 54. So 18 plus 3 is 21. Plus, let's break down 54. 2 goes into 54 27 times. 3 goes into 27 9 times. 3 goes into 3 times. So I get to take out a 3. There's already a 2. And a square root of 3 times 2, which is 6. So I get 21 plus 6 root 6. Okay, last one on the front is number 12. Same concept as number 11. I'm going to cross off that squared and write it again. And I'm going to double distribute. 3 times 3 is 9. Now there's no house, so do not put a house. 3 times the square root of 6 is just 3 square root 6. Square root of 6 times 3 is just 3 square root of 6. Square root of 6 times square root of 6 is the square root of 36. These combine, and I get 9 plus 6 square root of 6, and the square root of 36 is 6. So then I have 9 plus 6, which is 15, plus 6 square root of 6. Okay, let's flip to the back. Now we're rationalizing the denominator on all of the back. Okay, so let's start with number 13. These are simpler. So I know that I have a square root of 7 on the bottom, but it's as simple as it can get. So to get rid of the square root of 7, I need to multiply by itself so I can square it. So that gives me 2 square root of 7 over the square root of either 7 squared or 49. Well, that simplifies to 2 square root of 7 over square root of 49 is 7, which doesn't simplify, so there's your answer. So same exact thing on number 14. Multiply top and bottom by square root of 2. And I get 5 square root of 2 over the square root of 2 times 2, which is 4. So I get 5 square root of 2 over 2, because square root of 4 is 2. And 5 over 2 does not simplify. Okay, here, I want you to realize we can rewrite this separated. Square root of 15x over the square root of 2. And then it's exactly the same. So I'm going to multiply top and bottom by square root of 2. And I get square root of 30x over square root of 4. Well, the square root of 4 is 2. Let's see if 30 breaks down. 3 goes into 30 10 times. 2 goes into 10 5 times. Those are all prime and none of them match. So it does not break down. And this is your answer. Okay, 16, same concept. We can rewrite it as the square root of 5 over the square root of 3p. Now, always make sure it's simplified before you separate. 5 over 3 does not simplify further. 15 over 2 does not simplify further, so we were good to keep going. Now I'm going to multiply by the denominator to make it squared because it's a square root, so I need it twice. And I get square root of 15p over square root of 9p squared. 3 times 3 is 9. P times p is p squared. Well, 15p does not simplify over the square root of 9 is 3. And then the square root cancels the squared, and I get p. Okay, let's look at number 17. So again, this is just like those, except it has a minus or a plus in the bottom, 17 and 18. So we multiply by the conjugate, which just means it's the same thing, except the opposite symbol in the middle. So 5 plus square root of 2. Well, 2 times 5, I'm not going to simplify that yet. I can at the end if that 2 doesn't cancel. Over, we're going to double distribute. 5 times 5 is 25. 5 times the square root of 2 is 5 square roots of 2. Negative square root of 2 times 5 is negative 5 square root of 2. And then negative square root of 2 times positive square root of 2 is negative square root of 4. Well, the middle two terms cancel, which is why we picked the conjugate. And that leaves me with 25 minus the square root of 4, which is 2. Which leaves me with 2, 5 plus square root of 2 over 23. Which 2 over 23 does not simplify, so you can leave it. Or you can multiply the 2 through, it doesn't matter. Okay, number 18. Again, we're going to multiply by the conjugate. Okay, so we are going to double distribute. I always do the bottom first. 3 times 3 is 9. 3 times the square root of 5 is 3 square roots of 5. Negative square root of 5 times 3 is negative 3 square root of 5. Negative square root of 5 times positive square root of 5 is negative square root of 25. Which these cancel, which is what we wanted. We're left with 9 minus 5, which leaves me with a denominator of 4. Now at the top, I get 2 times 3 is 6. 2 times the square root of 5 is 2 square roots of 5. Negative square root of 5 times 3 is negative 3 square roots of 5. And negative square root of 5 times positive square root of 5 is negative square root of 25. Well, negative square root of 25 is just negative 5. 6 minus 5 is 1. 2 minus 3 is negative 1 square root of 5. Nothing here simplifies. That is your answer. Now, number 19 is easy to make it difficult, but you don't have to make it difficult. They are both cube roots. So just like here it was a square root and we separated it, we can go backwards and put it under the single house. So this can become cube root of 9 over 3. Well, what is 9 divided by 3? It's just 3. Cube root of 3 does not simplify because it's prime. There's your answer. So that one can be made easy, and it can also be made harder. Okay, 2 more. These are adding and subtracting, and you would need a common denominator, but you also have to rationalize that denominator. So I personally like to rationalize the denominator first, which means getting rid of the radical. Well, I only have a radical in this one, so I'm going to get rid of it by multiplying by square root of 3, top and bottom. So I get 7 square root of 3 over, 5 times the square root. 3 times 3 is 9. Well, that leaves me with 7 square root of 3 over 5 times 3, because the square root of 9 is 3. And that leaves me with 7 square root of 3 over 15. And I'm just going to bring this other guy down. Minus 8 square root of 3 over 30. That's a minus, not an equals. Okay, and now we need a common denominator. Well, I know that I can multiply 15 by 2, and it will become 30. So that gives me 14 square root of 3 over 30 minus 8 square root of 3 over 30. 14 minus 8 is 6. So I get 6 root of 3 over 30. And then we can simplify it. Well, 6 goes into 30, so divide by 6, and I get 1 square root of 3 over 5. So that's a little more work than number 21. 21 is a little simpler because the roots are going to match as soon as I rationalize it. So here I have a square root of 2 on the bottom, so I'm going to multiply top and bottom by square root of 2. That gives me 3 square root of 2 over 2 square root of 2 times 2, which is 4. Which gives me 2 times 2, because the square root of 4 is 2, which gives me 3 square roots of 2 over 4. Well, that already matches this guy. So 3 plus 5 is 8 square root of 2 over 4. And 8 divided by 4 is 2. There's your answer. Okay, test is tomorrow. Good luck. Study hard. Have a good night.